In the last video, I talked to you about what a neutralization reaction looks like and how you can do stoichiometry with it. When you actually do that kind of a reaction in the lab and you're trying to figure out if you have a known concentration of either the acid or base and you're trying to figure out the concentration of the other, what that's called is doing a titration. And I have also sent you a link to a video of someone doing a titration and walking you through it step by step. Now, you will not have the equipment to be able to do a titration. The long graduated pipettes are very expensive, and so, as people who are learning at home, we don't tend to invest in that kind of equipment. However, if at some point you do go to some other type of education, if you go to college and you take a chemistry course there, most certainly you will be doing a titration using that kind of equipment. So I at least want you to be able to see what it would look like. What I'm going to concentrate on today is how you would actually work the calculations after you finish the titration. You're going to be doing a titration yourself in experiment 11.3. It's just that you're not going to have the fancy equipment to do it with. So it's the same process. It's just going to be a matter of you're going to be using some much more simplified equipment. You won't be able to be quite as exact about it. So let's look at the sample problem for video number 6. It says 125 milliliters of nitric acid is titrated against 2.3 molar magnesium hydroxide. If 35.4 milliliters of the base was required, what was the concentration of the nitric acid? Okay, so first of all, let's kind of break this down and make sure you understand what's going on. You have a base, the magnesium hydroxide, that you know exactly what the concentration of it is. You know how many moles there are per liter. You know the molarity of it. You know the concentration of it. The nitric acid, you don't know what the concentration is. And if you're going to be able to use that in some other sort of reaction, you need to know what the concentration of it is. And so that's what the purpose of the titration is to determine how much of the acid you actually have present. And because the acid is in a liquid form, we're going to find how much of the acid is present in terms of its concentration. So just like in the neutralization problem that we worked before, anytime you work a titration problem like this, you have to start with the balanced equation. So in this particular reaction, we are taking nitric acid, HNO3, and we're reacting it with magnesium hydroxide. So balanced equation comes first. The magnesium and the hydrogen are going to switch partners because they're both positively charged. So the magnesium will go with the nitrate. Magnesium, being in the second column on the periodic table, has a positive 2 charge. Nitrate, as you should have memorized, has a negative 1. And so I'll need 2 of these in order to balance that. The H and the OH will then combine to become water. So acid plus base yields salt plus water. I have 1 magnesium on each side. I have 2 nitrates here, so I will need 2 over here. I have 2 hydrogens and 2 hydroxides, so that will mean I need 2 waters on the other side. Okay? Now, sometimes you titrate a base with an acid. Sometimes you titrate an acid with a base. You can go either direction. In this particular case, we know more information about the base, so that's what we're going to start with. So I know that I have 2.3 molar magnesium hydroxide, and I know that I've used 35.4 milliliters of it. Now, if you recall, molarity is moles per liter, so I've got to change that milliliters to liters, so that's going to be 0.034 liters, and then I will need to find moles for that. Okay, so when I multiply that out, that will give me 0.081 moles of magnesium hydroxide. Okay, now I need to use my balanced equation to figure out how many moles of acid I had. So I start with 0.081 moles of magnesium hydroxide. Put that over 1. The balanced equation tells me that for every 1 mole of magnesium hydroxide, I need 2 moles of nitric acid. So I'll put a 2 up here. So moles of magnesium hydroxide cancels out, and when I multiply that by 2, I will end up with 0.16 moles of HNO3. Well, now that I know how many moles of HNO3 I had, I was told that I had 125 milliliters, so I can now calculate the molarity, because molarity is just the number of moles over the number of liters. So if it's 125 milliliters, that's 0.125 liters, and so that will give me a final concentration of 1.3 molar. Okay, again, really nothing new here. We're still using balanced equations, still using the molarity definition, still using stoichiometry to calculate this, just doing it now in terms of a titration reaction.